here, so be funny. All right. Why is it so big? There we go. Everybody, on this page in your notes, we're not actually doing all the notes for squaring and reading inversions. We're going to do part of them, and then we're going to practice some problems. Okay. Okay. On the warm up, we need to know how to solve these, so we can do something with that down here. And on this one, you just did this. Some of you have worked on that paper. How can you solve for x here? What would you do first?
Try 21.
Okay, good. So x squared equals, what's 70 minus 21? 49. Okay, then x equals, okay, and it's not just 7 though. What is it? Right, plus or minus 7, because you always have two answers when you do square root. I didn't square root both sides. Okay, try B. I mean, it's very similar to this. Has a little extra step in it, but okay. And what I mean by B, I mean this one, the warm-up B. Okay, not down here.
Yeah.
Do we divide everything by 4 first?
Before you do what?
Before we
Square root it? Before you square root it, yes. Can't square root it until the x squared is by itself. Okay? That's a very important thing. All right? You have to have that, whatever squared, all by itself before you can square root it. Okay. Y'all getting decimal? Yes, that's fine. Okay. Did you remember to put plus or minus?
Yes.
Okay.
So if we put like 2.5
And
comma.
negative 2.5, yes, that's fine.
That's all we do.
That's fine. And you'll see it both ways. So either way is fine. So how did you do this? Add 12. 4x squared equals 25, and then divide by 4. Okay, now at this point, you could have left it as 25 over 4. Make that darker. Okay, or most of you made a decimal, didn't you?
Yes.
So you had x squared equals what?
6.2.
Okay, and then what did you do after that? Square root it, so x equals plus or minus 2.5, or a positive 2.5 and a negative 2.5. Okay, if you had left it as a fraction, what's the square root of 25? Okay, 5, and the square root of 4 is 2, and you would have 5 over 2, and that's the same thing as 2.5. Okay. Okay, now on C is a little trickier. So let's do this one kind of together.
Hopefully I got it right.
You might have. Okay, what could you do first?
distribute that.
Yeah, distribute the.
You mean this right here?
Yeah.
Okay, you can do it this way. It's kind of a long way. There's a little bit of a shorter way. Okay. What you want to do is get whatever is squared by itself. And so this is squared, right? So we could subtract the 4 to get it by itself. So square root of x minus 3 squared equals what?
36.
36. Okay. We're getting there. We're getting to what you said. Okay. All right. Now this whole thing is squared, so it's all by itself. We can undo the square. How do you undo it? Square root it. So we're going to square root both sides. Okay, and then the square root of x minus 3 squared, this square root and the square cancels, and you just have x minus 3 equals, what kind of 6 though?
Plus minus.
Plus or minus 6. Okay, so we really have two problems now. We have one problem where x minus 3 equals positive 6, and then the other one would be x minus 3 equals negative 6. So I'm going to separate those. X minus 3 equals 6, and x minus 3 equals negative 6. And then you can solve for each one. We'll add 3 to both sides, and x equals,
X equals 9.
and the other one, add 3 to both sides, and x equals.
negative 3.
Did you get that, Carmen? You did
I
it?
didn't
No.
think I need
Okay.
2.1.
Okay. If you if you multiply this out and then add 4 and then subtract the 40, you get something like x squared minus 6x minus 27. Did you get that?
That's fine.
Okay. So you had like this.
Yes.
Okay. Then from there you could use quadratic formula, or you could factor.
I had x squared minus 6x equals.
Ah, okay. You want to bring it over to the other side so that it equals 0. Okay. Like that. And then you can either factor it, and this would factor x times x was 27. 3 and 9, and you need a minus 6x, so minus 9 and a positive 3. And then the opposites are 9 and negative 3, which is what we got. Okay? So that is another way to do it. It is a little longer. Okay? All right, now, we're going to use this more when we get down to the bottom of this page. But for now, we're going to plot or find the points for y equals x squared, complete the table, and then plot it over here. So you can put in your calculator, or it's really pretty simple. What's negative 3 squared? What's negative 2 squared? Negative 1 squared? 0 squared? 1, 4, and 9. Okay. And then we'll plot those points over here and connect them. It's an equation, so we can connect them. Does it look like a quadratic?
This is the 135 rule.
It is, and
It's
it
just
goes.
regular X.
Yep. This is the parent function. So it's over 1 up 1, over 1 up 3, over 1 up 5. Good. Okay, now the next question says if the domain of the equation is negative 3, negative 2, negative 1, 0, 1, 2, and 3, then what would be the range?
Everything X is, or Y is greater than 0.
No, well,
Greater than or equal to
no, let's do specific numbers.
Oh.
These are specific numbers, so the ranges will be
9, 4, 1, 0.
okay. And we don't need to put the 9s twice or the 4s twice. So let's start with the smallest one. What's the smallest one?
0.
0. Good. Okay. Okay, is this equation a function? Is the
Yes.
X is not repeat.
x's do not repeat. What else? What about the graph?
Pass the graph along.
Good. Passes VLT. If I put VLT, you remember what that is? Okay. Yes. Okay. All right. So this one's a function. Now what we're going to do is the inverse of that. You remember how to do inverses? What happens to x and y? They switch. So all the x's were put in the y column. So we'll put all the y's in the x's. We switch the coordinates. This would be 9, 4, 1, 0, 1, 4, 9. Okay. So anytime you need to do an inverse, you switch x and y. Then we're going to graph this. So it's going to. What happened to the graph?
It's flipped sideways.
It looks like it rotated, but it actually flipped over what line?
The Y.
X.
Or X.
The y equals x line. So if you kind of sketched it here, I wish they had graphed this on the same graph so you could see it,
Oh, yeah.
you know, but it flipped this way. Okay? here, and you could kind of sketch it here. That might help to see the difference. Okay. Is this inverse a function? Why not?
That's
That's
X.
your vertical line.
Okay. No, fails vertical line test or fails VLT and X's repeat. So once you invert it or switch X and Y, then it's not a function anymore. Okay, now what we're going to do is find the inverse of the actual equation, y equals x squared. And this is where we're going to use those methods that we used at the top. Okay. Okay, remember that another way to find an inverse is to switch the x and y variables. Okay. So what would the new equation
X
be?
equals Y squared.
Okay. That is the inverse equation. X equals y squared. Now what we want to do is actually solve for y, or get y by itself. So let's write it right here. X equals y squared. And then what steps will we use to get y by itself here?
Square root.
Okay, you want to get rid of the square. So we get square root. Okay, now when we square root something in an equation, what do we get? Plus or minus. So plus or minus the square root of x equals y. Okay, now we've got y by itself, right? But we're going to use a different notation. This is an inverse notation. F to the negative 1 of x means the inverse of f of x. Okay? So it's another name for the inverse, another way of writing it. But it means that the inverse has to be a function. So let's go ahead and write f of x, f negative 1 of x equals plus or minus the square root of x. We're just replacing the y with this. Now we need to see if this is a function or not, though. Okay, so let's graph it. How can we graph that? Kind of tricky. Can you graph part of it?
Yes.
You could graph what?
Positive x squared minus x. Or, x squared.
Positive square root of x. Okay.
and Y.
All right, so let's do that. Second square root of x. Okay, and we'll graph it. Now, what about the negative part? Could you
Then
graph it?
shut.
Let's graph it in y2. Okay, so negative second square root of x.
There it
There it is. Okay, now the problem is, though, is this a function or not?
No.
No. Okay, so it can't be the answer to this because this one says that it has to, this f of x means it's got to be a function.
Wait, what did you put in one, two?
I put in negative square root of x. I put in the positive square root of x in y1 and the negative square root of x in y2. Okay? But we have a problem. This is not a function. How can we change this so it would be a function? What could you do to the graph to make it a function?
Put square root
We could maybe get rid of that part. If we get rid of the negative part, is it a function now?
Yes.
Yes. Okay. So let's get rid of the negative part, and we leave the positive part, which means that really we just have the square root of x. Okay. And if we sketch that over here, it looks like this.
In this, like,
Okay.
this is one, it looks like logarithm.
Except for logarithm actually starts at, so the parent function usually starts at 1. Okay. And it has a different curve. It's hard to tell, but it does have a different curve. Okay, does this graph match the one up here?
Yes.
Except for what?
The bottom line.
The bottom half. So we're going to say actually no, because,
There's no bottom.
and why do we not have a bottom half?
It would be.
There's no negative.
Because it wouldn't be a function. Okay. We got rid of that negative so that it would be a function. Okay. All right. Now, you're supposed to have this other part. You don't. So you just watch this. Okay. All right, we're just gonna look at the difference between y equals x squared and the inverse of it, okay? This equation is y equals x squared. What's the shape called? U-shaped or parabola, okay? All right, now, if we're gonna do the inverse of this, how do you do the inverse?
You switch the X and Y.
You switch the x and y. What is it gonna look like over here if I do this inverse of that?
It's gonna look like sideways.
Sideways, okay. All right, so their graphs are reflected over the line, what line?
X, Y.
Y equals x. So if we do that line there, you can see that they are reflected, okay? And then their equations have the x and y switched. So let's switch x and y. What do you get for the equation?
Y or x equals y squared.
All right, and this shape, what would you call this shape?
Sideways.
Sideways parabola? Okay. I like it. Can you see okay, Jim?
Yeah.
Sorry.
It's fine.
Okay, and what did we say the problem is with this graph right here? Not a function. Okay, so normally we don't draw both the top and the bottom. We just graph the top half and call it the square root function. Okay, so the square root function is this part. That's it. So then it'll be a function. Now you have this little piece of paper. Okay, this is the parent square root function. The square root parent function. Okay, we're going to finish filling out the table and graph it, and then we'll put it
Are we
in.
using this in there?
Oh, yeah, just leave it. Here you are. Okay, so on this table, we got, if you plugged in, the square root parent function is the square root of x. If you plug in 0, square root of 0 is 0. And then the square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. What would be the next whole number?
16.
Okay, square root of 16 is 4, and then
25.
25 is 5. Okay, then we'll just plot these points over here. We can't do them all, but we'll plot the ones that will fit. And that's what your square root function looks like. And the parent function starts at what point? 0, 0. Okay, so we're going to find the domain and range of this parent function. Domain is left to right, so where does it start? On the left.
0.
And then does it keep going to the right?
Yes.
So how could you write the domain for that?
X is
Put a
greater
dot
than
at
or
it.
equal to 0.
Good. X is greater than or equal to 0. Huh?
Dot at 8, 3.
Oh, thank you. Thank you so much. Okay, that's better.
You only
Sort of.
use-
Sorry.
Can you only use whole values for x?
No, because like square root of 2 is 1 point something.
Oh.
But it's just, when we're graphing, it's easier to use whole values. But yes, x can be anything greater than 0. Okay? All right, so you can only use positive values
Okay.
for x, any positive value. And this is only for the parent function. Okay, now the range is from bottom to top, so where does the range start at?
1.
Greater than or equal to 0.
Good, very good. And you will only get positive answers for y. Because if you're putting in something positive over here for x, you're going to get a positive answer. Okay, what if you put a negative in here?
It'll be imaginary.
It'll be imaginary. You get the square root of a negative, and that's why we don't have any negatives. Okay? Okay, glue this in to your next page.